and this course ends on Saturday. And I'm working on next course, which is 520, and it will be available by Sunday evening. So from Monday, you can start 520. And another thing is that
Oh, really? Yeah, it's just like a listening situation.
what happened? Okay. So basically, this course is prerequisite, as you know, and prerequisite, you have to have minimum grade in order to move to the next course. So this course is not hard and fast to, because 75% work is already there in terms of assignment. So those who are getting 100 out of 100 in all the assignments, and exam is not difficult, conceptual. So let me start with this week. And this module is not included in the final exam or final. Can you see my screen?
Yes, thank you.
Okay, so before going into that, let me start with the basic concept of this module with whiteboard. So it starts with correlation and regression. So first we need to understand correlation. What is correlation? Relationship between two variables. So basically in statistics, when you studied chapter 1 or chapter 2, they have univariate analysis, bivariate analysis, and multivariate analysis. They are different analysis. So uni, that you were dealing with only one variables. Bivariate, you are dealing with two variables. And multi, where you are dealing with more than two variables. So far we did this one, univariate, where most of the time we were dealing with only one variable. Now we are going to deal with two variables together. So this module is bivariate analysis because two variables together. Now let's start two variables. Let's see this x and y. And if you plot two variables together, let's say something like that, this is coming a graph of x and y. Let's say this is. So there is a correlation which is represented by a small r, and it's called correlation. And it is simply meaning the relationship between two variables. And r square is regression coefficient. It means how one variable impacts other. So, or r square or regression is also known as causal relationship, how one is causing the impact on other. So r square or is a regression. So we are going to cover simple regression, correlation and regression. So first, let's talk about what is correlation and let's see how it works. When you have two variables together, let me generate some data and let me explain. So I'm just creating dummy data. Let's say here you have experience, and here you have your salary. These are the two: experience from 1 to 20 years and calculate random data integer. And I just said, let's say 30 and experience, and I'm giving 1 is minimum, 20 is the maximum. Okay, so this is experience of some and how much salary. So I'm just going to do and now I'm going to do instead of and 1 2, so minimum 60,000 and maximum value, let's say I put 120 or 140,000. Okay. So this is someone's experience and this is their salary. Now I would like to see, is there any relationship? So I just go under statistics, basic statistics, and I can go for correlation. And here we have Pearson or Spearman. Store correlation matrix. By default, 95% graphs. You can see the graphs, results, pairwise. And now, so basically, if you see this result, our random data doesn't show any relationship because R is, this is less than, this is about 6% or 7%, you can say, because data is highly scattered. Suppose it is, in trend or something, it would have R value. So R value can range from -1 to +1. Means how this is -1. So this is X and this is Y. How it can be -1 means X value is increasing, Y value is decreasing. So like this kind of graph. This is negative correlation. One is increasing. Let's say your experience is increasing, but your salary is decreasing. Other thing, positive correlation. X is increasing, Y is also increasing. Your experience is increasing, your salary. So R is positive. Or 0 means no, like, this is almost, this is 7%, which is almost close to 0. Means it doesn't show any pattern in this data. So -1 to, where R square regression is 0 to 1. 0 means this, 0 means no causal relationship, and 1 is 100%. So, but there's a beautiful thing that you must know: only simple regression, correlation multiplied by correlation, that comes to regression. Correlation plus correlation, that becomes regression. So this is very important. In simple correlation, coefficient is given, you can do multiply with same value and you can get the R square. Just so, and so this is basic concept. So this is a correlation. And now you can see whether this correlation is useful or useless. So the null hypothesis says, rho equal to 0. What is rho? H null hypothesis for correlation. H1 rho is not 0. That means rho, so small r is for correlation for the sample that we have here. Rho is for entire population. So population correlation is 0 and based on sample, and this is not 0. And again, same concept applicable. What we say when p value is greater than alpha value is 5%. What is your judgment? What is your conclusion? When p value is greater than alpha value, we accept null hypothesis. So basically, in other word or simple word, we can say this is useless. When entire population correlation is 0, in simple wording or applied wording, we can say useless. But when not 0, this is useful because there is some relationship. So this is how we get this. So this you can see. Now, if it is clear, I go to the next concept. So first we have to check the correlation before moving into regression. If you see the correlation is valuable in something, okay. Otherwise, let's go for, so regression. What is regression? As you know, simple straight line or simple line equation is y equal to a plus b x. X is this, y is this, a. So if you draw the, let's say, for example, this, you draw this line between two variables. This is a. This is called intercept. So this is called a. What is b? B is nothing but these two. If you take 2 points on line anywhere, draw perpendicular and horizontal lines. So I draw perpendicular and horizontal lines. So perpendicular, and now the difference in this difference and this difference. So basically this is called del y, difference in y, difference in x. So so a is nothing but intercept, b is nothing but this. So b equal to, it is called slope, it is called gradient, it is called del x. So you can get this value. So y equal to, and this equation is helpful to predict any x value, what would be corresponding y value. So this is regression. So it is helpful for many things for predicting. So this is a concept of regression. Now let me get a good data so that I can demonstrate to you something real, because this data is not giving real information or something valuable inside that you can interpret. So let me try. Or let me make the data from my side. one more thing that I would like to explain before going with the data. Let's say this is X, this is Y, and the graph is coming like this. I mean, these are the points. Let's say you plot the line between X and Y, and you put the fit line. Fit line is coming like this. Okay, this is a fit line. This difference, this is minus, this is plus. These are called error terms or error values from the fit line. So basically, this, so this is minus, this is positive, positive, minus, because all the lines will not be on same line, same fit line. All the points will not be on the same fit line. Therefore, this is error. Are these error are normally distributed? There are many hypotheses. So the hypothesis comes for null hypothesis comes for regression is all constants are zero. Are zero. So this is all constant means intercept plus intercept and slope. Alternative says at least one constant is not zero. Means at least one constant is not zero. What will happen if all constant will be zero? Then if you understand by equal to a plus bx, all constant will be zero. This is zero. This is zero. Y will be zero. If at least one will be non-zero, then you will have some meaningful value. So these are the few important things. Now let me start with some real, some data points and so let's say I'm just making some significance or use full data, and then we can do the, let's say I'm going to start here. It's a experience and salary. So okay. So now let's start. Somebody with 5 years experience, what do you think? What would be the salary? So let's say somebody with 75,000. Somebody with 10 years salary, a 10-year experience salary would be about 110. Fresher 0 year, like 1 year's experience would be about 65,000. Some logical here, it not logical. So let me put some 10, 20 points, almost 20. So 4 year, and then I would say 80. 6 years, I would say 79. Then I would say 8 years, and I would say 105,000. 9 years, and I will say 110,000. 2 years, and I would say 65,000. 3 years and 70,000. 5 years, 80,000. 7 years, 90,000. 15 years, and I would say 120,000. So 13, 14 years, and I would say 105. 12 years, and I would say 115. Let me do 5 more, and 5 years again, 105. 8 years and 108. 11 years and 110,000. I have to put one more zero. 16 years and 125,000. 20 years, and I would say it's 125,000. 17 years. Oh, sorry, I put wrong. And let's say I put 118,000. So this is little bit logical data I formulated, and now I do the same thing. Stat basic, and I go first to check correlation. And I delete and I select both together, and since all the results, everything. So when you put this pairwise correlation, then only you will get the p-value. So basically now we have to do everything based on p-value. So now you can see there's some positive relationship. Means you can see, if you see the fit line, it is increasing order. Now correlation, you can see 89%. The relationship between experience and salary is about 89%. Clearly you can see. Now here you see the p-value. That means what you say, null hypothesis, say rho equal to 0. Alternative says not 0. So the same principle from past module, that is, it is not non-zero. It is useful. Correlation is useful. So always think what is the null hypothesis, useful or useless. So this is useless. So you can see p-value is p-value is less than 5%. Automatically null hypothesis is rejected, alternative, and it says useful. So this correlation is useful. Now correlation is 0.89. Let's see. So if I want to see the regression, R square is equal to 0.89 into 0.89. And now you can see whatever number we get, the same number we will get. So now I go under graph, statistics, regression. This is regression, and we are going to use simple fit regression model. We are not using, there are many types of regression. We are just learning simple fit regression model. So fit regression model. Now you have to understand what is the response variable and what is the continuous variable. So response salary depends on what is the dependent variable? Salary. Salary depends on number of years of experience. So salary is dependent variable and experience is. Now here you see we have different options, which I'm not going into this. So let's go. And now you see, this is the equation that we did. Y equal to AA plus BX. So salary equal to 67915 plus 338. So if you can see, okay, here you see. So this is intercept. This is slope. Now we want to see whether this is useful in the model or useless, or this is useful or useless in the model. So we are going to look into. Now this is constant. This is constant. Constant is, this is the value of constant. You can see this is intercept value. Now again, you see the p-value. Are they useful? What is the null hypothesis? Null hypothesis says all constants are 0. Alternative says at least one is, or one is non-zero. Okay, so constant is useful in this equation. What do you say? Because now you have the numbers in front of you. What is your decision?
You will reject it? Reject the HO or the null analysis?
Yes, that's correct. It's reject the null hypothesis. And so basically null hypothesis is useless. Useless is null hypothesis here, useful. So what we say, this is useful because p-value is this. This is also useful. So in this. Now you get the, now based on this model, you want to, let me clear. Based on this model, you want to predict if you have like 30 years of experience, what would be your salary? So I can go here, statistics, regression, fit regression. Here we have predict. And now experience, I have 30 years of experience. What would be my this? And now you can see this is third fit value is coming 170,000 about. So if you put 30 here multiplied with this plus this, you get about 170,000 value. So you can predict, you have this much experience, what would be your salary. Anyway, I come back on the same thing. So here you can understand this is a model, this is significance. Now let's try to understand the relationship among these things. So what is the, this and this and this, these are interrelated. So if you have two value, either you have coefficient, standard error of coefficient of t value, out of these three, you have two of them known, you can calculate the third. So I'm just going to show you this. So this divided by this, you get the t value. So where's my calculator? So 6, 7, 67915 divided by 4213. Let's see what is the value. We get 16.2, 12, which is t value. So if you know t value and the standard of error of coefficient, you can get the coefficient. So this is t value. Similarly, you can do so basically they are interrelated. Two values, you can calculate the third value. Okay, so this is coefficient, t value, standard error in coefficient. Now you come to this. Now here I said r square. So what was our correlation? Correlation was 0.89. So r square, what is r square? And let's see. 0.89 multiplied by 0.89 and we get 0.7921. So same value we get here r square. So now how we interpret this r square? R square means 79% changes in salary is due to experience. 79% change in salary can be explained by experience. So basically different way of explaining. So basically this is a coefficient of determination. It says this experience is the cause and salary is the reason. So cause and effect. So basically 79% of your salary can be determined based on experience. In simple word, but 79% changes in salary can be explained by experience and different way to frame the sentence. But this is, so R square is 79%. Here clearly, what is adjusted R square? Adjusted R square is, basically if you see in this observation number 15 is a little bit odd, unusual, and it doesn't fit properly in the model. So maybe some error, something. So basically, adjusted R square is more refined value, more refined R square value, which excludes all the unnecessary or some different kind of unusual observations or useless items. It exclude from the analysis. So R square adjusted is always smaller than R square. So let's say this is a simple regression. If you have multiple regression, your salary based on experience, education, and this many variables, then maybe some variables are not useful. So it may remove that from the, so R square adjusted is always little bit lower than R square. R square, this is further lower and we don't use in our analysis. So what is this is standardized. So this is another thing which is, this is a deviation of the salary in the model. Now look into the model value. So regression, this is overall regression is useful or not. Overall R square and overall regression is useful or not, we can understand from this value. This is regression. And this is the, so basically this, you have to always concentrate on p-value. Null hypothesis is useless, alternative. So overall regression is this. And overall regression is useful because p-value is less than this. What is regression statistics? This is called regression. Regression statistics is F value, F distribution. Okay, rest of the things. So this is what you need to know. And at later stage, you can get to know what are the unusual observation. That means what observations are not fitting in the model. So let's see what is the 15th number observation and what we did. So 15th number. Okay, so 5 years of experience and 105,000 salary. This is what we did a mistake. And data, I mean, either we did wrong entry, our error, or somebody has reported wrong, or maybe something extraordinary person who has only 5 years of experience getting this much money. So basically, we have to go and check and see why this is coming, because it also gives some unusual thing. Okay, if this is correct, somebody extraordinary in that, okay, keep it. But it gives you the indication. Okay, rest is all good. So this is simple regression. Now here under this, we have many assumptions that I'm going to explain one by one. Now, one assumption is multicollinearity. Actually, that is a serious concern. But in simple regression, we don't have this multicollinearity issue because VIF is 1. If you have more than 2, because 2 or 3 independent variables are highly correlated, they will demonstrate the same kind of behavior in the model, and that can cause multicollinearity. So if VIF factor, VIF variance inflation factor. So this is the factor that indicates. So I'm just going to give you the brief information about those things. So we are using ordinary least square. So basically all the formula equations that you can see are equal to minus plus whatever, these are the different correlation, -1 to +1. R square is 0 to 100, 0 to 1. So null hypothesis, alternative hypothesis, how you can calculate the T, since everything is calculated there. Simple regression. So here, this is simple regression. So regression model, this is error term, intercept, slope, intercept. So basically, we are not learning all these typical calculate these equation and all. We are just going into interpretation of the numbers. Excel also gives the same output. So basically, if you look into the Excel, but in Excel, you have to include the one thing which is called one more thing that you need to include in add-in to do the regression analysis. So slope, intercept, and F-test. Now, residual test, like I said, residuals are normally distributed, error are normally, so whatever error based on each are normally distributed or not distributed. So basically, residual test, errors are normally distributed, null hypothesis alternative is not distributed. So we are going to look into that. Then it's a heterosydetic or not homosydetic, non-constant variation. So this is another test. Though I don't have these in this module, we will cover in next course, 520, heterosydetic and homosydetic situation, autocorrelation, and that can be DW, Darwin-Watson test can explain that. So errors are not out. So if DW value is less than 2, so these are the interpretation. And residual test. So basically, So let me show you one by one what we are going to. These things we will cover more in next module, which is multiple regression. So there is a very simple way. Here you can have assistant. Under assistant, you can see many things. Here, hypothesis. Now you go to regression. You select multiple regression or simple regression. So we are dealing with simple regression. By column is salary. X column is experience. Okay. And alpha, you can do this and you can do simple thing. So this is plot. I mean, I think I selected wrong model, but here you can see this is model plotted. And now we go to under statistics, regression. I'm just showing you so that we can, but these are not included in this week assignments. So here you can see results. Under this, I also include this. Here you can see analysis of variance, method, regression equation, all you can get here. Storage, here you can get the residual. Means you can get the fit value, you can get the residual value, error value. So basically residual or error. And now. So this is fit value, this is residual, this is standardized residual. So let me show you whether it is not normally distributed or distributed. So I go here. Here we have under graph, and under graph we have probability plot, and we have single, and we have residual. Sorry. And now you can see whether it's normally distributed or not normally distributed. So this is probability plot of residual, and you can see within p-value is greater than alpha value. So what is your conclusion? What is your conclusion? P-value is greater than 5%. This is, we are checking at 95. So what is your conclusion?
Useless.
So basically here, normality and not, so we can go here back on. Errors are normally distributed, errors are not normally distributed.
So then errors are normally distributed.
That's correct. Because p-value is greater than alpha value. So always think, what is the null hypothesis and what is the p-value. So we are having the almost normal linear probability plot. So this is first thing, our errors are normally distributed, non-constant variation. And you can see if you look into this funnel, then funnel in or funnel out, then this is heterozygotic. Now let's look into. So basically we did in here, this is what do you see? What pattern can you see in this? So this is the one, and this is heterozygotic. So basically I'm not able to recognize it's a funnel in or funnel out situation. And I would say this is like a not a strong curve and not cluster, unequal variance. This looks like a large residual. Now we see the Darwin-Watson test. So where's the value of DW test is 1.466. And what is the meaning of this? 0 to DW value is 0 to 4. If DW is less than 2, positively autocorrelated. Equal to 2, no autocorrelation. More than 2, negative autocorrelation. So errors are non-autocorrelated. And here, errors are autocorrelated. So basically here, second hypothesis is correct. Alternative one is correct. So basically we will discuss these things in next course. I don't want to give you a lot of burden in last week. So just complete the assignment of this week, and it is not included in the final test, but it can give you some insight that what is regression, what is the correlation. And from there so this is bivariate, and next course is about multivariate analysis. So any question, any comments, any doubt, please feel free to ask.
Professor CT, I got a question on one of the assignments or exercise. Is asking for to calculate the confidence and prediction intervals for Y.
Okay. So look into, yeah. So just a minute. So here. So basically when we predicted what would be the salary when I have 30 years of experience. So this is a confidence interval. This is a prediction interval. And prediction interval lower range is this. And so what is the confidence and what is the, based on this 95% confidence based on a sample. But when you predict, this is a prediction interval.
Can you do that in Excel?
Yeah. Sorry, I didn't get your...
Is there a formula that we can calculate that in Excel?
Oh, to be honest, I did not try this in Excel.
Okay. Can you show us again one more time? How do you get to that again?
So basically, most important thing, this, let's say, okay, here I remove. Now we go to statistics and we go to regression and we can't do the prediction. So prediction, when you want to run the prediction, first you run the model. You cannot directly run into the model. You cannot directly run into prediction. First model, first you need to train this Minitab. What is model? Then next time you go to predict. So this is 2 step. Since already I trained, it is already taking, but first you go regression, fit regression model, and regression model is about same. So this is our regression model. Now next step you go and you do prediction. So statistics, regression, and predict. Even this predict option will not appear until you train Minitab about the model. So now you go and you just put what is the experience. So first time, let's say, what is the experience? 30, experience 22. And let's say, so for 30, this is a prediction interval. For 22, this is the, so you will feel that, without doing the model, you cannot directly predict. So first step, always run the model, regression, then second step to go for prediction. It's very easy and simple.
Are the confidence intervals in this always two-tailed test?
Yeah, so basically confidence interval is always lower and higher. You remember the first and the last, I think last module or before last module. So before hypothesis, module 4. So called confidence interval, this is lower and higher, always two side, 95, 45, whatever, level of confidence you select. So it has lower value, it has upper value.
Okay. Yeah, thank you. I think I saw in Minitab there's like drop downs that say lower bound, upper bound. I didn't know what if that meant it was like somehow left tail, right tail, but maybe not.
So in this module, we are not doing any left tail, but that is related to hypothesis, left tail, right tail, upper bound, lower bound. That is, for distribution. So for example, the previous situation in hypothesis test. So let's say this is normal distribution and this is for lower bound, lower value. So basically, let's say, so confidence interval in this situation, in this situation, if lower 5%, so this minus 1.4645 all the way to infinite. This is the range of, so this is the lower 5% and this is the, if you do opposite, this is the, so the range is, lower is minus infinite and up to 1.645. So confidence interval always has two values, lower and upper. Any other question? If no, then I would like to say, have a wonderful evening, have a wonderful productive week ahead, and all the best for exam. You can do in 30 minutes if your concepts are clear. It will not take,
Professor,
yeah.
sorry.
Yeah, go
In
ahead.
Minitab, it says respawn, so that is Y, and predictor is X, correct?
Sorry. Now you please tell me because I removed my headphone. I'm not able to hear properly. Now please go ahead.
So in Minitab, when we are pulling in the regression, response is Y and predictor is X
Yes.
for the line.
Yes. So here, let's say regression, fit regression. So response is dependent variable and there are two types of predictor. This is like a categorical predictor. If you have four, male, female, or different categories, then you can put the variables here, but I'm just using. So continuous predictor means independent variable, and this is dependent. You are having something different?
No, I just want to verify that with you. If response is which way does it go, the X or the Y?
So yeah, this is Y. Dependent is always Y. Response is dependent. So like I say salary based on experience. So this is always Y.
Got it.
Okay. Any other question?
I do have one more question. So on chapter 12, it does have two sections. It's called optional. It's the other regression problems and the logical regression. Do we need to know that for this module for this week?
No. I mean, you need to know very simple few things. Simple, the predictor. And I think I also reduced the number of questions. No.
Okay, thank you.
Yeah, so you don't need to go into depth because we will cover in multiple regression next module, next course.
Okay, thanks.
Okay. So wish you all the best, and 40 questions, mix of both, and you can do in 30 minutes. And yeah, it is very easy. So thank you very much, and all the best, and good night, and see you on next week with next course. Bye-bye.
Thank you. Bye.
Bye.
Thank you.
Thank you.